Okay, today's lesson is over writing equations of lines. Okay, we're going to write an equation of a line that's parallel or perpendicular to a given line and passes through a given point. So we're going to write an equation of the line that passes through the point -1, 1 that's parallel to this line. Okay, so we remember that the point slope form of an equation of a line looks a lot like this. No, it does look like that. So all you have is your ordered pair, which is right here. The x and the y values of your ordered pair are right there. So we're going to substitute in the x and y values from your point into the x and y values there. This y and this x are going to stay as x and y. We also need the slope from this line. Okay, and that's where the slope is coming from. So all we have to do is fill in all three of these values. So y minus, and we look up and find what the y value is from our ordered pair. We see that it's 1, so we put a 1 there. Remember, this sign is minus. So if that were a negative, we would change it. The m, the slope. Well, the slope is the number in front of x, so in this case it's 2. And then we're going to put x. This sign is a minus, and then what's the x value? Well, it's -1, so it's going to be minus a negative. So y minus 1 is equal to 2 times x plus 1. Now what we need to do is distribute 2 times x and 2 times 1. And then the last step is to add 1 to both sides. God, my pen is off. Add 1 to both sides so that it is in the form y equals mx plus b. So this is our slope-intercept form of an equation of a line. That's how you do it. So your ordered pair is given. They give you the x and y, and your equation is given, and that gives you your slope. If it's parallel, which it is, our slope is exactly the same. If it's perpendicular, we'll have to make a change to that slope, but I know that you know how to write a perpendicular slope. This slope is 2. Right now, the slope for this equation is 2 over 1, so that's supposed to be an equal sign. The perpendicular slope would be -1 over 2, and we would use that here if it was asking for a perpendicular line. Okay. Write an equation of a line that passes through the point -1, 5, or that's a positive, 1, 5, and is parallel to the given line. Okay, so since it's already on the graph, well, either way, I've got the point 1, 5 and the equation. So let's just follow the same rules. We're going to use our point slope form, y minus the y value equals the m value, which is the slope from this equation. Do we want it to be 3 for parallel, or do we want it to be -1/3 for perpendicular? Well, it's parallel, so we're going to keep it exactly the same. And then x minus, what's the x value? The x value is 1. So now I just distribute first, and then move my 5 over. So I'm going to add 5. That's all you have to do. That's all you do every time, is distribute and then move whatever that is being subtracted from y. So y is equal to 3x plus 2. Now when I graph that, 3x plus 2 starts up here at plus 2, and I have to go up 3 and over 1. Well, I run way off the graph, so instead I'm going to go down 3 and to the left 1 and put my points. And you can see my pen is off. So I should have 2 parallel lines right there, ready to go. Write an equation of a line passing through the point 2, 3 that's perpendicular to the given line. Perpendicular this time, so my slope is not the same. And look at how my equation's written. My equation is not written in slope-intercept form. How do I change this to slope-intercept form? I need to move my x over because I want y by itself. For slope-intercept form, y has to be alone. If I move the 2x over, it becomes -2x plus 2. And you probably knew it was a negative slope because look at the line. Now, my slope is -2, but my line that I'm trying to draw an equation for is a perpendicular, so it's not gonna have a slope of -2, it's gonna have a slope of positive 1/2. So my slope that I'm gonna use for this equation is gonna be positive 1/2. All right, so point slope form, y minus the y value equals my slope, and then x minus the x value. So I'm gonna distribute 1/2 of x is still half of x. 1/2 of -2 is -1. And then after I distribute, I told you you just get rid of this number. So y is equal to positive 1/2 x, and that's gonna be +2. So when I graph it, I go to +2. Gosh, that is also the point they're gonna have in common. And I have to go up 1/2. Probably should actually do up 1/2. Up 1/2, and it's kind of in the way. So I'm gonna also go down 1 and to the left 2 a couple times so that I have a nice pretty line. So there you go. You can see that they're perpendicular. You can see that they make a right angle. You can see that our slopes are not the same for these two lines. They're opposite reciprocals. They do have the same y-intercept. That is also the point where they intersect. That's all I got. Write an equation of a line that passes through this point and is perpendicular to this line. This line has a slope of 2. If it's perpendicular, my slope will not be 2. My slope will be the perpendicular slope, which is, again, -1/2. So now I just fill in to the point slope form, y minus the y value equals my slope, -1/2, x minus the x value. In this case is -2. So I'll change this to +2. So again, y minus 7 is equal to, let's distribute, -1/2 of a +2 is going to be a negative, and 1/2 of 2 is 1, so that's -1. Now I just need to add 7 to both sides, and my equation is going to be y equals -1/2 x plus 6. How do you know the lines x equals 4 and y equals 2? Well, remember, x equals equations, that's the vux. Those are vertical lines. They look like this. And this line, y equals 2, and it's a y, that's a Hoy line, which has a 0 slope, and it's a horizontal line. How do you know? Because they have opposite reciprocal slopes, and because one is horizontal and one's vertical. It's going to be, these are going to be lines that are actually straight all along the grid lines. Find the distance. Okay, now here's a different type question. Find the distance from that point to this line. Now the thing is, when we're finding a distance, the distance is along the perpendicular line. So we have to make sure that we know what our slopes are, because we need a perpendicular slope. This slope is -1, right? Because the number in front of x is -1. So my slope is -1. My perpendicular slope would be +1. So from this point, I want to travel a +1 slope. I'm going to go up 1 and over 1. That's going to get me right here. That's the distance. Now, how do I find that distance? Well, remember, it's along a diagonal, so I need how much the x changed, how much the y changed, and I need to do 1 squared plus 1 squared. This is the distance formula. So this is the distance, which is the square root of 2. And I'm just going to leave it because I don't have a calculator. I'm sure it's 1 point some decimal. But that's the distance right there. How do I find the distance? I have to travel from the point to the line along the perpendicular. And this is where you definitely want to have scratch paper if you're doing something like this. Find the distance from this point to the line. Okay, so we're going to definitely use our graph paper. So we're going to graph the point 6, 4. So 6, 4. and we're also gonna graph the line. If the line has a slope of 1 and a y-intercept of 4, to graph it, I go to 4, has a slope of 1, so it's gonna go up 1 over 1 from that point. And really what I need is a better looking graph, so I planned ahead and I already graphed it. So let's look at this. I want to know the distance from the point 6,4 to this line. Remember that this line has a slope, of 1. So for me to travel from this point to the line, I have to travel a -1 slope. -1 slope. So if I'm traveling -1 slope, I could also go up and to the left, which is actually better because it's going to actually go toward this line. So what I need is the distance from this point to this line, which is this triangle right here. So I'm going to do 3 squared plus 3 squared and take the square root. So that's the square root of 18, which if you simplify it is 3 square root of 2. And you've done a problem like this before where you had an across and an up and down that were the same, and we found it to have that number with the square root of 2. So hopefully that's starting to be something that you memorized. All right, we're trying another one. Okay. All right, for the second equation, which I just changed, we've got the distance from the point 2, 7. So I'm going to put my point at 2, 7 and graph this line. Well, this line has a y-intercept of 1 and a slope of down 2 over 1. Down 2 over 1. Well, if my point's here, perpendicular is going to be, so I'm going the wrong way. So I need to extend my line going the opposite direction. Okay, so I'll have a line that looks like this, goes through 1, and it has a -2 slope. And I want to travel from this point to that line. Well, how do I do that? Okay, so let's get this out of the way and get my better looking graph up here. All right, how do I do this? My slope right now on this line is down 2 over 1. So my perpendicular slope, remember that's how I travel from the point to the line because we always want to go perpendicular. So my perpendicular slope is going to be the opposite of this, positive 1 over 2. So from here I'm going to go up 1 over 2. Up 1 over 2. Well, I'm going away from the line. So I want to go down 1 over 2. Down 1 over 2. And that's the point that I would meet the line. So I want this distance right here. So how do I find distance between 2 points? I want to know the distance from here to here. I just have to make my triangle that has a 4 across and 2 up and down and 2 squared plus 4 squared. So that's a 4 and a 16. So it's the square root of 20 and whatever decimal that is. So that's how you find the distance between, and always do this on a graph. Make sure you have a piece of graph paper. It is so much easier than any other way that you do it. Don't forget the slope-intercept form of an equation of a line looks like this.